Okay, welcome to today's lesson on reflections. So a reflection is just a transformation where we're going to kind of like flip an image or a point. So today, by the end of this video, we should be able to perform a reflection in the coordinate plane over any horizontal, vertical, or 45-degree line. Before we can do reflections, we need to talk about what a line of symmetry is. So a line of symmetry is a line in which you can reflect or flip a figure over and the figure appears unchanged. It divides a figure into two congruent images. So take a moment and visualize or draw in these lines of symmetry for each figure. Alright, so let's look at our rectangle here. So a rectangle has a line of symmetry going vertically, and it has one that goes horizontally. Rectangles do not have diagonal lines of symmetry because the corners will not lie on the exact same spot. It will actually rotate it slightly. A rhombus, on the other hand, has diagonal lines of symmetry. So it goes corner to corner each direction. A rhombus does not have vertical or horizontal lines of symmetry. What about a perfect or a regular hexagon? So regular hexagons have lines of symmetry straight to the center of each side. So I have a line of symmetry through each of the sides on a hexagon, but hexagons also have lines of symmetry through the vertices. So those would be all of his lines of symmetry. A circle has lines of symmetry anywhere that you draw that line. As long as it goes through the center of the circle, it's going to be a line of symmetry. So a circle actually has an infinite number of lines of symmetry. So now we've prepped ourselves to look at reflections. So to do a reflection, what we're going to do is we're going to draw in our line of reflection first. And then we're going to determine the distance or count the boxes between our point and the line of reflection. And we're going to take that and duplicate it to the other side of the line. And reflections are always perpendicular to the lines of reflection, okay? And then we'll connect all the image points when we do figures. But one thing to note is diagonal lines, so y equals x or y equals negative x, that's when you're going to count diagonal boxes. So that's just a lot of information. Let's look at how this actually works. So example 1, reflect the point 3, negative 5 across the y-axis. First thing is plot your point, 3, negative 5. And we want to go across the y-axis. So I'm going to identify my y-axis here. That's my line of reflection. So to reflect this point across the line of reflection, we always go perpendicular. So this is vertical, so we're going to go horizontally. And we're going to just count boxes. 1, 2, 3. So to reflect it, we need to go the same distance to the other side. 1, 2, 3. So the reflected point, A prime, would be negative 3, negative 5. What about going across the x-axis? Start off, plot your point. Negative 2, negative 4. Let's call this one B. So that's our point B. Now we want to go across the x-axis. The x-axis runs horizontally. Why don't you take a moment and try reflecting B first. Count the boxes, find the new point. Okay, so B is 4 boxes below my line of reflection. So I'm going to go 4 boxes above my line of reflection. And this point here would be B prime. So B prime, -2, comma, +4. So hopefully at this point you're starting to see this pattern evolve between counting the boxes to our lines of reflection and then just duplicating it. But what if I don't use an axis? What if I'm using the line y equals -2? We're still going to start with our point. In this case, 3, -4. We'll call this C. Put your line of reflection on the graph. So y equals -2. On your y-axis, find -2 and then draw a line through that. This is your line of reflection. We only count boxes to the line of reflection. 1, 2. C is 2 boxes away from the line of reflection, so count 2 boxes to the other side. 1, 2. And this would give us our C prime. C prime, 3, 0. So always count to the line of reflection. That's why it's important that we draw that in. Use a highlighter or something potentially to make it really stand out. So here's another one that's not an axis. 3, 1 is our point. And we want to go across the line x equals 4. X, find my x-axis. At 4, put a point and draw a line through that point where x is 4. That's our line of reflection. Now you try, take this point, we'll call it D, and reflect it over the line x equals 4. All right, so D is 1 box away from my line of reflection, so I go 1 box to the other side, and that's D prime. So D prime, 5, 1. So no matter if we're using the x or y axis or using a line y equals a value or x equals a value, we're still just counting those boxes straight across to that line. Here's a different type of problem. Now we're reflecting over the line y equals x. So the point -2, 4, we'll call this E. And we want the line y equals x. The line y equals x, this is like saying y equals 1x plus 0. So here's a y-intercept of 0 and a slope of 1. Up 1 over 1, up 1 over 1, up 1 over 1. So this diagonal would make up our line of reflection. When we do diagonals, we want to count the diagonal boxes because reflections always happen perpendicular. Okay? If I was to count straight across, that's not a 90-degree angle, so it's not perpendicular. Perpendicular or a 90-degree angle is going to come down on this angle like this, diagonally. So what we're going to do is count these diagonal boxes. 1, 2, 3. So go 3 to the other side. 1, 2, 3. This here would be E prime. So the coordinate of E prime is 4, -2. All right, so let's get started on this one. This is another diagonal reflection. So 1, 3 is our point. And this line would be the same as y equals -1x plus 0. So the y-intercept's 0, and now we're going down 1 over 1, down 1 over 1. So this builds up our line of reflection. And I can extend it both ways. Why don't you take a moment, we'll call this point F, and try reflecting this line, this point across our line, y equals -x. Okay, so remember our line is diagonal, so we're counting diagonal boxes. 1, 2. 1, 2 to the other side. F prime. So the coordinate F prime, -3, comma, -1. So vertical and horizontal, we count vertical and horizontal boxes. Diagonals, we count diagonal boxes. Now, in this case here, we have a reflection already done, and we need to find the line that it's already reflected over. This has its own type of process. The first thing we're going to do is, 1, connect image and pre-image points. So what I mean by that is I'm going to take C and connect C with C prime. D is going to connect with D prime. And E will connect with E prime. For step 2, we're going to count how many boxes are between those new segments and divide in half. So if I was to look at the segment C, C prime, that's this top line here. How many diagonal boxes do we have? 1, 2, 3, 4, 5. So this segment is 5 diagonals long, so we're going to divide that in half. 1, 2, and a half. And notice I'm saying 5 diagonals. The diagonals is not a unit, it is a diagonal, okay? So we don't want to confuse that up. And now do the same thing for D, D prime. So this middle one, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 diagonals long, so half of it would be 4.5. 1, 2, 3, 4 and a half. And now my last one, E, E prime. 1, 2, 3, 4, 5, 6, 7, 8. E, E prime is 8 diagonals long, so half would be 4. 1, 2, 3, 4. And now you can see all 3 of these dots line up, and that would make our line of reflection. This would be reflected over the line. So this is going to be y equals, and because it has negative slope, y equals negative x. Let's do one more of these. Okay? So remember, the first step is connect pre-image and image points. Then our second step, count boxes and you're going to divide that by 2. So why don't you take a moment and try this out first. Draw those segments in and then find the halfway point between them. Alright, so the first thing is we need to draw these segments in. V to V prime, U and U prime, T and T prime. And then step 2 is count how long these are and divide that by 2. So V prime is 1, 2 boxes. So half of that would be 1. U prime, 1, 2, 3, 4, 5, 6, 7, 8. So 8 segments, 8 boxes long. So half would be 4. 1, 2, 3, 4. And we have T prime. 1, 2, 3, 4. Half of that would be 2. 1, 2. And now we can connect these hash marks, these little dashes. And that gives us our line of reflection. So this one would be a reflection over the line. And this is across the line. Y equals 1 because it goes through the y-axis at 1. Okay, so just some things to remember. Always draw on your line of reflection. If you have x equals a number, those are your vertical lines. They go up and down. And y equals a number goes across. Do not confuse that with your x-axis and y-axis, though. And always remember to count perpendicular to the line of reflection. Or in other words, diagonal lines count diagonal boxes. And that's it for today's lesson.